Okay, guys, let's go over those examples in your book. So we got this situation here. We got a 20 kilogram student. Gravity is equal to 9.8. We're assuming that the whole motion of that student is going to be frictionless. There's going to be absolutely no resistive force, and the angle of inclination is going to be 15 degrees. They want you to figure out the acceleration that the female student slides down the ramp by. Okay, again, there's value in doing what we've been doing with dynamics problems. Sort out your axis, sort out which direction is going to be positive and which one's going to be negative. Here, just for the sake of confusion, we're going to choose this side as positive, this side as negative. Top is still going to be positive, and the bottom is going to be negative. Okay, we've done that. We've got conventions. Start thinking about Newton's laws. Are there any forces that are going to cancel out? Well, yeah, we're going to, we know this one, this weight force can be broken down into components, F, G, cosine 15, and that's going to balance with the normal force. And we're expecting that the sine component of the weight force is going to cause that object to slow down the incline. So let's have a look at what's happening at the forces in the y direction. We're going to say that Fn minus Fg cos theta is going to equal to 0. And the forces on the x direction, all we have is Fg sine theta. We're expecting there's going to be motion, so we can use Newton's second law and say that there's going to be some kind of net force. Right? So remember, F net is equal to ma. So that's all I've done. Rather than write F net there, I've just assumed that the net force is happening. So therefore, I can define it in terms of this part of the equation. Right, and we're solving for acceleration, so we can do that, right? We know that that's 20 kilograms. We know that the weight force, the gravitational field is 9.8, so therefore we can calculate that. So let's do that. So we calculated the weight force equaling 196 newtons. So we can substitute that there. 196, the sine of 15 degrees. MA is equal to 196 sine of 15 degrees, 51 newtons. We can solve for acceleration. We know that the mass is 20. (51) divided by 20 is equal to A. (2.55) 2.5 meters per second squared. Okay, let's have a look at the next example. Okay, this is example 2. Example 2 gets a bit harder because they've added friction in there, and they haven't given you a normal force. So you're going to have to use Newton's laws to solve for values that aren't there, or extrapolate for values that aren't there. Okay, so here's the diagram. We've got the car, it's at 60 degrees. It's got a mass of 200 kilograms. It's got a coefficient of static friction of 0.9. So at some point, it's no longer going to be static, and it's actually going to start moving. And we're trying to figure out, on the basis of the tires and the gravel, which apparently has a coefficient of friction of 0.9, if that is exceeded, then that car is going to start accelerating down, not rolling down and accelerating. It's actually going to start sliding down with its rubber tires down that incline. So we're trying to figure out if that's going to happen, and if so, at what acceleration is it going to be doing that. Okay, so let's have a look at here. We know that's FG, which we have, and that this one over here, that's going to be the cosine component. This is going to be our sine component. This is going to be our normal force, and this is going to be a frictional force. We're going to treat this side as negative, this side as positive, this side as positive, and this side as negative. As long as we're consistent, it should be okay. All right, so we've done that. We've got our conventions, we've got our diagrams. Next thing is to have a look at Newton's laws. So yes, again, in this situation, we got the forces along the y-axis that have to be in equilibrium, they have to equal to 0. So that's going to be our normal force is going to be equal to the cosine component of the weight force. Let's have a look at what's happening with forces. On the x-axis, we have Fg sine theta minus frictional force is going to be equal to a net force. Now we can define frictional force like so. Mu Fn is going to give you some kind of net force. Okay. Now we've done all this, that's excellent. We've got the problem here that for frictional force, unfortunately, we don't have a normal force, right? But we're going to have to substitute some kind of value. So we know that the normal force is also equal to the cosine component, so we can just substitute that in there and solve for that. So let's solve for the normal force here, and we can put that value there. And we can clean this up a bit more. Okay. So we calculate the weight force. So the entire weight force of the vehicle is equal to 19,600 newtons. And what we can do now is, now that we have that Fg value, we can go onto this side and solve for the cosine component of the weight force in order to get that normal force value that we need, so we can substitute here. So we proceeded to do that. We figured out that the normal force, or the pressing force between the surface, the car tires, and the gravel is 9,800 newtons. So now we've got a value that we can put there, and we can solve the rest of this expression here. Okay, so we've done that. Fg sine 60, we've got Fg, 1 19,600. That gives us that value with our frictional force. We know our coefficient is equal to 0.9. We know our normal force is equal to 9,800. So that's what we've done there. We've ended up with this value. We've subtracted this, which shouldn't be a point. And we end up getting this, 8,154 newtons. But that's saying because there's a total force F net of 8,154 newtons this way, then you're going to be expecting this car to be accelerating down the slope. So we can do that. Substitute the rest of the expression in, which is mass acceleration, 8154. 8154 divided by mass. Mass was 2,000 kilograms. The acceleration is 4 meters per second squared. So that's going to be increasing. Every second is going to be increasing by a velocity of 4 meters per second squared. So yeah, that's going to be